All right, hello. Let me turn off this relaxing music. So here we are again. This is the second in a series of streams that we're going to do where the goal is to get technical and to actually show you, the listener / viewer, how to do something and how the technical aspects of some piece of the Web3 work. And today we have Christian Seifert from Forta. Have I butchered your name? Or is that
no, you got it right. Hi, everybody. Hi, Chad.
Hey, good to see you, and thank you for doing this. And what we're going to do today is, first we'll learn what Forta is, and we can probably spend just a little bit of time on that because it will become very clear as we start building. And then Christian's going to walk through how to build a bot that we can deploy into Forta. And maybe, Christian, you can just start by telling us what Forta is, and I'll probably ask you some things about yourself as we go.
Okay, sounds good. So Forta is a decentralized network that monitors transactions in real time for threats. And kind of the high-level components of the network consist of scan nodes. So think of these as full nodes, that, for example, an Ethereum node, that then essentially take every transaction and every block and then forwards that to a set of so-called detection bots that then contain, machine learning models, heuristics that analyze the block or transaction for indicators of attacks. And then if something is detected, an alert gets emitted. And of course, the ultimate goal of the Forta network is to secure Web3 in that we want to detect these attacks early, such that protocols are able to jump in and mitigate the attack.
Great. Is there a centralized Web2 sort of equivalent to this kind of thing?
Yes. I mean, I think so I originally came from Microsoft, working at the Microsoft Defender group, and the Microsoft Defender offering kind of is the equivalent in the Web2 world. It particular kind of falls into the EDR, or endpoint detection and response capability. And that is actually fairly new. I think kind of the category emerged, I want to say 6 years ago. And before that, in the Web2 space, what companies, enterprises primarily relied on is, antivirus and firewall to protect themselves. And I think what the industry came to the realization that is not sufficient. What if an attacker slips through the cracks and is on your network? How do you identify that and protect your network then? And very similar to what's happening in Web3, you have protocols going through smart contract audits, which are essential and valuable to secure a protocol. But things slip through the cracks. And so then the question is, what if something slips through the cracks? And that's where really Forta fits in by monitoring on what's happening on the protocol in real time.
Cool. Thank you. And your background, you're actually a security researcher, is that right?
That's right. Security research with a flavor of data science. So I've been, before coming to Forta, I've been at Microsoft for 14 years, working in the Web2 security space, but always realized that the security research will have limitations in terms of generalizing and scalability. And so that's kind of where data science comes in and kind of lifts it to another level.
Cool. And one more question before we start looking at code. What drew you to this blockchain Web3 stuff from where you were at Microsoft?
Well, I think just learning about Web3 got me really excited about the censorship resistance, the distributed nature, and the accessibility of that technology on a global scale. And so I was learning about it kind of on my weekends and on the evenings, and I just and got more and more passionate about it. And then at a certain point in time, I was like, well, if I'm so passionate about something, why don't I make it my day job? And so that fortunately happened with Forta, and I've been here now 3 months as the researcher in residence, and It's been awesome.
Great. Well, welcome. And why don't we then start making this concrete and take a look at some code?
All right. Well, let me first share with you kind of the type of attack that we will be looking at.
All right.
So this was an attack that happened on June 23rd, and Uno Fun Maximalist tweeted about it. And so what he observed was a contract that is deployed on Ethereum mainnet that looks very similar to a contract from Convex Finance. And the similarity here is really the first 4 characters of the contract and the last 4 characters of the contract are the same. Now, why would an attacker choose to do that? And I think it stems from the fact that, contract addresses are not very readable. They're long. And also you have limited real estate in the UIs that are being presented as you interact with Web3. So here you actually see a signature request, and this is a MetaMask screenshot, where you see that kind of the middle portion of the contract address is actually truncated. And so if you're able to, if you want to launch a social engineering attack, tricking users into some action, making that address look similar to the legitimate contract is going to be, another step that an attacker can take to make the attack more believable. Now, this is again a MetaMask screenshot. I would assume that on mobile devices, it is even more commonly truncated that way.
Yes, yeah, it is. And I would guess that anyone using MetaMask or a similar wallet is guilty at some point of just looking at the first and last parts of an address, right?
Yeah, so all the listeners should check the entire address, but at the same time, we will be working on a detection bot that exactly will identify this condition. And so let's take a look at the transaction, the attacker transaction. And so the way a transaction looks like for a contract creation, it is just a transaction that contains a from address. So this is the EOA of the attacker, as well as
what EOA stands for.
Externally owned account.
Okay, so that means like a normal wallet of a human.
That's correct.
Okay, thanks.
And the transaction is unique in that it contains a from address, but there is no to address. That kind of indicates to the Ethereum virtual machine, hey, this is likely to be a contract creation transaction. And then the contract code is submitted in the data field, in the input data. What this transaction, like Etherscan, of course, kind of parses it and shows it into a more human readable format. And so what they already have done is tell you, here's the contract address that is going to be used. Now, if you look at the raw transaction, you actually do not see that contract address because the contract address is actually calculated based on the Ketchak hash of the EOA and the nonce of the account. And the nonce is essentially just kind of a transaction counter. It increases with every single transaction. So since this particular EOA, let's just kind of look at it here real quick. So here you see all the transactions from the attacker. So the out is the only out transaction. So the only transaction that the attacker initiated, and therefore the nonce is 0. And so you basically take the EOA, concatenate it with the nonce 0, you take the Ketchak hash, and that is essentially the contract address of the contract that will be created. And so what that really means is you're able to take an EOA, and you're able to theoretically calculate all the contract addresses that EOA is ever going to be deployed. Now, how did the attacker create essentially this transaction? So the contract address looks similar to the legitimate existing contract, which is this one. Well, what they must have done is they essentially generated EOAs randomly and then calculated based on the nonce 0 what is the contract address that will be created, and they must have done millions of permutations to get something that matches at least the first 4 and the last 4 characters.
Wow. I would bet there's some code sitting on GitHub now that does this that we can just download and use.
Yes.
Right? Yeah.
Probably GPU assisted, and so it's super fast.
Yeah. Wow, sneaky.
Yes, very sneaky. And so so just talking about the bot now. So the bot essentially will monitor incoming transactions for contract creations. And then it will need to check a list against any deployed contract, right?
Yeah.
In order to see, hey, is it similar or not? And if it's similar, then it will raise an alert. And then the alert will actually show up here on the Forta Explorer. So think of Forta Explorer as kind of the ether scan of the Forta network. It contains all the various alerts that are raised by the various bots. And so we would see something similar to this, a transaction, some details. Hey, this account created a contract that looks similar to another contract, and then a link to the Etherscan a transaction. And protocols then are able to subscribe to that. So in this particular case, right, Convex Finance may subscribe to that particular bot. And then if they receive an alert, well, they could inform their community saying, hey, there is a scam going on. Here's the attacker contract address, and kind of warn users that way.
Yeah, cool. And when you say protocols can subscribe, you mean humans that are involved in managing those protocols, right?
That's correct. There is also the ability to kind of subscribe via an API and then kind of hook that up into like automated incident response processes. So if you have, let's say, an attack on a protocol, alert gets raised, the protocol could configure it in a way where they automatically pause their protocol, for instance.
Cool. Great. Okay, so the bot you were talking about is the bot that doesn't yet exist because you're going to show us how to build it, right?
That's right. So let me pull up my window here. Well, actually, let me just, before we go there, let me share one more thing. So this is the Forta documentation. And so if you go to building detection bots, it shows you how to do that. So I already have my environment set up. So there's Node.js, Python, and Docker that you need. And then you basically, to create a new bot, you create a new directory, go into the directory, and then we will execute this particular command. And it will basically generate a skeleton bot. Now you can develop bots in TypeScript, JavaScript, and Python. Given my kind of background on the data science side, I am very, very partial to Python. And so I have, let me share my screen here of my.
And that was docs.forta.network.
That's right. Yeah. Okay. So hopefully you can see my Visual Studio window now. So I have my my directory, tutorial 5 for the bot, and then we'll execute this command. And then basically it pulls all the files down that are needed for a bot. And I'll walk through the files here in a second.
Cool. And do all the bots end up getting deployed into Docker? Is that how it works?
That's correct.
Okay.
So it's essentially on the scan nodes. You then have every bot deployed in an isolated Docker container that then is also, resource constrained, because we don't want to have a bot, impact a scan node negatively or influence the behaviors of other bots that are deployed. The other thing that happens is bots are actually deployed on multiple scan nodes at the same time to create some redundancy within the network.
Right, makes sense.
So in terms of kind of the overall outline, so as I say, it kind of generates a stub here. And so the bot code itself is in agent.python, essentially. And it's called agent. We kind of renamed it recently from agent to bot, but really we're dealing with bots here. There is the requirements file that contains all the libraries that you may need in your bot, which are then incorporated when you build the Docker container, a README, and that will then essentially be available with the bot in Forta Explorer. So when you encounter an alert, you can go to the bot page, and then you can actually see this particular documentation file. Then you have a couple of JSON files that kind of configure the bot. There's some changes that we will have to make here. And then the Docker file containing how it is built. We don't need to make any changes here. And then we have a unit test file. Now there's a few things that you can do to run your bot and test your bot. So npm run test would execute the unit test. npm run start, and we'll go through these when we completed the bot to kind of show how it looks like. npm run start will essentially listen to the transactions that are occurring on the network in real time and forward them to your bot. So you're able to essentially test your bot against live traffic. An npm run transaction allows you to back test your bot. If you recall the couple of transactions that I pulled up on Etherscan, well, that was a real world attack of this particular technique that we're trying to detect. And so that is a good test case, right? Of, hey, does it work?
Yeah. So you mean you can actually copy those transactions in to run through the bot whenever you want?
That's right.
Nice. Yeah. And I see on the unit testing, you've got mock stuff set up sort of in the stub, so you can easily get started doing unit tests without talking with the network. Yeah.
That's right. That's right. Because we want to make sure that we're able to kind of control all aspects. We don't want to be dependent on live data in the unit test. That's kind of where we use, the real transactions, and then also kind of testing against the live network.
Cool.
Now, one thing that we need to decide on is, as I mentioned, transaction comes in, we assess whether it's a contract creation. And then we want to test it against a list of deployed contracts. Now, the bot does not have these lists of deployed contracts. And there's a variety of ways one could obtain that list. A bot is able to reach out to the web and make web requests. So a bot could certainly query a service like Luabase, which is essentially an indexer on blockchain data, and then kind of provides a SQL-like interface to query that. So you could certainly have a bot that then queries Luabase and says, give me all contracts. That's one way to do it. It will create a little bit of a dependency on an external service. And then you also need to decide, well, how often do I update that? Another approach is that you could just have a queue where you look at every single transaction that comes into the bot, and you assess, is that transaction or is that user interacting with a contract? And then you store that in your queue. And that's kind of the strategy that we'll apply in this particular bot. And the reason why we'll do it this way is, if you're thinking about it from an attacker perspective that wants to impersonate an existing contract, well, first of all, it's going to be a contract that is used extensively, probably recently deployed. And so just kind of reasoning through it, kind of like a queue like that will very likely have that contract address in the queue. If we're using something like Lua base, again, external request, then we have 5 million contracts that are on Ethereum today. Then you may run into kind of memory and constraints, and maybe even processing time constraints. And so I'm kind of opting not to go down that route.
Right, and the bot has access to every incoming transaction potentially, right? So it can see everything that's happening on the public network.
That's correct.
So you could even do something over time where you count different wallet addresses interacting with a contract, and it gives you more of a sense that these are important contracts. Because it's unlikely, I would guess, that someone's going to do this attack on a contract address that almost no one uses too.
That's right, exactly. That was my thinking here as well. And so we'll utilize it that way. So the first thing that I tend to do when I create a bot is I work on the documentation first. And the reason for that, it just kind of creates more clarity for me in terms of what the bot is supposed to do. And also it will create clarity in terms of what sort of information it will need in the finding, and essentially in the alert that is getting emitted. So this one again.
I have a dumb security person question for you then. You've typed social engineering contract creation bot. I'm guessing what you mean here is that you expect that this sort of attack would be deployed by reaching out to someone via email or chat or something and convincing them they're doing something, like one of those people that's always spamming me on Discord.
That's right. It's probably going to be, like an attacker that will create this contract. They will likely create a web page that then kind of also emulates the dApp of the underlying protocol, and then probably spam out links, either by email, Discord, etc. Twitter is certainly popular in the crypto space, to get you to use that dApp. You look at the dApp, everything looks fine. You then sign the transaction. You see, hey, the particular contract address, you may kind of compare that to the protocol, legitimate contract, and get fooled by just the fact that kind of the first and the last 4 characters are the same.
Great. And by great, I mean bad, of course, but I understand.
So this one is about detects that if a contract is created that is similar to an existing contract based on the contract address, and here we can even be more specific: first 4 cars and last 4 cars. Now, this bot will be deployed on all supported chains. And just for the listeners, Forta network today supports 7 EVM compatible chains. So that's Ethereum, Binance, Polygon, Arbitrum, Avalanche, Optimism, and Phantom. And there's nothing here specific in this bot that would constrain it to just one of those. I think it should work generically across all chains. So then we basically have to specify what the alert will be. So fires
I was wondering how you were going to do that. So first 4 and last 4 characters of the contract address being the same versus something like string similarity, something like that, which makes more sense, I guess, in this case.
Yeah, that's a good point, Chad. I think there are, also why is it 4? Why is it not 3? I think there is probably, we're creating kind of the initial version of the bot, and there's probably kind of different types of attacks that kind of fit the general theme, but not necessarily this particular pattern. And in security, you always kind of need to start somewhere, and then you observe what attackers are doing, and then kind of adjust. Or as I mentioned earlier, utilize more data science approaches that generalizes across the general attack patterns. The challenge that we have in the blockchain space is that, while it's certainly perceived that there's a lot of attacks out there, it is still fairly small compared to, let's say, what you see in the Web2 space, right? Like in Web2, you see millions of phishing mails every single day. And in blockchain world, maybe dozens, maybe hundreds of phishing attempts.
Yeah, they've just been more noticeable lately. Because they have unfortunately been pretty profitable for the attackers.
That's certainly a little different if you steal, my Google credentials versus my NFT, which I don't have.
Right.
So going back to kind of the README, so basically an alert will expose, there's an identifier that you need to specify that then will kind of show up on the alert page. You need to specify the severity and the type. And in this particular case, I will specify a high severity and type exploit. Currently, there is no social engineering category. It's probably something that we need to introduce. And then in the metadata, we will include the information of the impersonated contract. And that is important because the transaction that is responsible for generating this alert will not have that contract, right? So if you pull it up in Etherscan, you don't know. And so that's something that we then need to include in the alert data of what contract is being impersonated.
Makes sense. Cool. So filling in the README first gives you both some grounding in what you're going to get done, and also causes you to do this so you don't forget and end up with nonsense on Forta Explorer at the end.
All right. And then we basically have 2 transactions here that we will include. So this agent behavior will be tested on, and we can also include the Twitter link. These 2 transactions then essentially are a test case that we can use later to test this particular bot.
And also good information for whoever's looking at the README.
Okay, so then kind of the next thing that we'll do, we'll just kind of give this bot a better name than Forta Agent Starter Kit.
So this is interesting. You're building in Python, but you're configuring everything with NPM as if you're doing a JavaScript project or a TypeScript project. I guess you've just built all the tooling using JavaScript. You don't have to recreate it in Python every time.
Yes, exactly. So yeah, the Python actually is, kind of a small component of the entire bot. So then I also specify here the chain IDs. So these are the 7 EVM compatible chains that Forta supports. And this is required essentially to tell the network on where to deploy the bot to. And we have another configuration file where we just kind of specify the name. And I think that is it in terms of configuration that we need to change. And so then kind of the next step that I personally do is create my unit tests first. And the reason why I do that is it just, I run the test, it fails, and then I code up the agent. And once the test succeeds, well, I'm done. Now, I will only, for the purpose of this demo, create kind of happy case, test case.
Right, because it's boring to write all the edge cases for someone to watch. Yeah.
Yes.
Doesn't really help you understand how to make a bot.
So we'll simplify it a little bit more, and let me just change my interpreter here. We go to Forta.
It's so nice to see someone doing test-driven development for a case like this.
Yeah, maybe it's related to the fact that I'm just a bad coder.
Well, I think we all are, and therefore we should all do this. That's certainly why I do it.
So for tests, what we want to do is make sure that we are using mock objects. And I will just kind of copy paste something here because that it's very much kind of standard code here. But basically, this Web3 mock essentially mocks the Web3 JSON RPC endpoint. So when our bot actually talks to essentially the blockchain via the Web3 API, in the unit test case, it will not talk to the real blockchain, but rather to this mock object. And that gives us, less dependencies on network, et cetera. The unit test is really self-contained. And it gives us a lot of control. So for instance, we can control what is a contract, what is an EOA, what code do we get back, et cetera.
It also means the tests will run really quickly because they don't need to make network requests and do IO and all that.
Yes, that's a good point.
So there is a Web3 library in Python that talks to, is it Ethereum nodes directly through the RPC endpoint?
Yes, and it is very analogous to Web3 JS. It's Web3 PY.
Cool.
And so the kind of the API interface is very similar. So then, okay, so first, what this test will need to do is we'll need to initialize the agent with the Web3 mock object. And I don't know whether you're noticing, you're seeing a lot of kind of predictive text. Again, I'm maybe not a great coder, and so I need all the help I can get. And so I'm using Codex, which is kind of a predictive coding assistant.
Good.
From Microsoft, and it certainly makes my life much easier. So it's initialized, and so first, what we want to make sure is that the contract queue is empty, because basically, in order, so what the unit test will do, it will essentially send 2 transactions to the bot. The first transaction is just a regular transaction that will interact with the legitimate contract. And the way the bot will use that transaction, it will extract the contract address and add that to the queue.
Right, to its known list of contract addresses. Yeah.
Exactly, known list of contract addresses. And so then the second transaction will be really the contract creation transaction that we then use to compare against the known list of contracts. So the first step of the bot will really be, am I storing the contract in my queue of known contracts? And so we'll create a mock transaction event.
And mock here, is this a standard Python mocking library you're using?
I think it is.
It's not a Forta thing, though. It's some Python.
Yeah, no, I don't think it's a Forta thing. But basically, what we use it for is we will mock out essentially the transaction, which essentially has a from, which is the EOA address, and then the to, which is the contract, the legitimate contract.
Yeah.
And then we
did you mean to have an underscore after the from?
Yes, because from is a reserved keyword in Python, and so we're going to need to do that. And then essentially, if you look at the agent, and this of course is still the template agent, and we'll change that. But the main function is the handle transaction function, and what it passes in is a transaction event. And the transaction event will contain all the information that you would expect from a transaction, like from, to, input data, nonce, etc.
Right. So this is the standard API for all agents that has handle transaction, and Forta is doing the work somewhere between the RPC endpoint and here to create a useful object for you.
That's right. And there's two interfaces. There's a handle transaction, and also you can, there's a handle block where you get the entire block. The other thing that bots are able to do is they're able to cache state, just like how we're doing here in kind of the generating a list of known contracts.
Right.
So then we pass in that transaction event, and then basically what should happen is our contracts queue should have grown to 1. And then we'll do this again. And this time, you will not pass in a to address. And what that indicates, hey, it is a contract creation event. And then the other thing that we will need to pass in is the transaction nonce, which in this case is 9. Don't get hung up on why it's 9. But basically what happens is on this particular transaction, a contract gets created that where the address is calculated based on concatenating the EOA address, the nonce, and then taking the check hash.
Right.
And then what should happen here is this handle transaction event returns a list findings, and findings, again, kind of a little bit of a renaming. Findings is essentially an alert, and so a handle transaction event can generate multiple alerts, and so it's a list. And so here we just check that the findings length is 1, because an alert should be generated.
Yeah. So the API of handle transaction says that if there is a non-empty list at the end, there are alerts. Is that right?
And you could, of course, again, I'm simplifying the test here a little bit, go into details of the finding, look at the description, the metadata, the severity and making sure that that all matches your expectation. Again, for demo purposes, I'm simplifying it a little bit here.
Yeah. Looking at just the test, I can see that, or I can test my assertion with you anyway, that if there's a non-empty list returned from handle transaction, then alerts will be generated. If there's an empty list, then no alerts will be generated.
Right.
Yeah, makes sense. Nice and simple.
So let's see whether we can actually run this.
So we expect it to fail, right?
We expect it to fail.
Error.
Yeah, right now, I mean, it's not even running the test. Well, the actual agent. There's still an error somewhere. Let's see here. From webmock. Got the contract here.
Contract view address. So my Python joke is that probably there's some white space you can't see.
yeah, no, that is probably the case. Well, we'll continue. We'll get the test running.
All right.
So again, there's a lot of kind of template code that is generated here. We'll just kind of rip all of that out and start from scratch. And so there's a few functions that we will require. So there's already the initialize function that I mentioned, where we basically have a Web3 object. And so we need a Web3 object, which is essentially the interface to the JSON RPC endpoint.
Mm-hmm. This codex is cool.
Yeah, I won't be able to go back, but sometimes you have to be a little bit careful. Like sometimes it certainly generates code that is nonsensical. And
Yeah.
it does a lot of it based on comments. So you can have like a comment, and then it analyzes the comment. And
interesting. I wonder sometimes if my dependence on GPS for driving places is good or bad for me ultimately. Same sort of thing, I guess.
And the funny thing is, when I first learned how to code, I was at a small startup, and we were coding in Java, and everybody was using either VI or Emacs. So there was no kind of formatting, no syntax highlighting. And you certainly became a very good coder that way.
I confess to being a VI user myself.
I was more on the Emacs side.
So not being a Python native person myself, it looks like you're defining like a constructor and a class and a method in a class, but there's no class.
Yeah, the agents are not set up as classes per se. So we're just kind of, or maybe it is a class and we're just overriding some or inserting some function and overriding some functions.
Interesting.
All right, well, let's go into the handle transaction. So as I mentioned, we first need to have a global.
Got the L and the O swapped in global still. Global.
A contracts queue. And so the way I will implement the contracts queue is actually as a Pandas data frame.
Oh.
And the reason for that is we want to make sure that we have fast lookups. And we are not just storing the contract address, but rather we will store the contract address, the first 4 characters, and the last 4. And the advantage here is, by doing it this way, is that we don't need to iterate through a list and then kind of parse the contract address, and that's just going to be too slow. We'll just kind of store it. Let me see here.
So Pandas data frame is a data structure that makes this sort of look up fast. And do you have to add that to your requirements explicitly, or is it just there by default for Forta?
Oh, it's something that I need to add. So a good point. So we'll first import Pandas as PD, and then we of course need to match that up with the requirements, and I think it's Pandas.
I would be really impressed if Codex figured out the right version.
Yeah, that would have been awesome. Okay, so then going back to our agent, so we got our contracts queue, which is the data frame, and we probably also want to initialize that here. And the reason for that, again, is more on testing purposes. We don't want to have one test state or test case influence the state of the agent for the next test case. So we always want to kind of start with a clear slate. And so we'll reset the contracts queue. So then basically we have our transaction event. And so if the transaction event 2 is not none, and the transaction event
so you're checking if it's a contract creation now,
right?
Yeah.
But then the transaction event 2 address will be empty. And so then the other thing that we want to do is we will lowercase the address. Hang on, let's see here. Actually, this is nonsense because we don't have a contract.
Mm-hmm.
The way we get the contract is we need to calculate the contract address, right? So again, so the contract.
So someone was interacting with a contract in this case, not creating a contract.
Oh, right.
And we want to see what the contract address was that they were interacting with and put it in the contracts queue.
I was confusing myself here. So
this is why we're pair programming. We're doing test-driven development and pair programming. We're almost doing extreme programming from the 90s.
Yeah, I did that too with Emacs, right? Because I didn't have highlighting. So yes, so these are the transactions that come in first, right? Somebody is just interacting with a contract. So here the 2 address should not be none. So hey, somebody is interacting with something. We don't know whether it is a contract or not.
Right.
And so we need to determine if it's a contract first, and then we'll continue. So let's implement this particular function first. So dev is contract.
As an aside, this style of work I really like, where you just act like the function exists so you can speak your native language, and then you go implement the function that does what you wanted it to.
So in order to determine whether an address is a contract, you need to use the Web3 API and call this function getCode. And I know that this particular function will require the checksum address of the address. I don't know whether you've seen this, but basically, let me go to the mock page. Yeah, so here, basically, as you notice that the letters are not all lowercase.
Mm-hmm.
There's kind of camel case, right? And basically that is the checksum format of an Ethereum address, where if we have like a typo like this, it will no longer validate.
Okay. That I did not know about.
And certain APIs want to have the checksum address. Certain APIs do not. Sometimes you get kind of, depending on where data comes from in a transaction, you get the checksum address. Sometimes you do not. And so it makes it a little bit of a pain in the butt, because you got to make sure that it is consistent in your code.
Mm-hmm.
And so what I tend to do is, as I did here, I lowercase everything. And then when it is required, I change it to a checksum address.
Okay, cool.
And the way essentially, in order to, the way to assess whether something is a contract, you call the get code function, which just pulls the code that is behind the address. And if the code is not equal to 0 bytes, then you know that it is a contract.
Mm-hmm. Makes sense. Otherwise, it's an EOA. Is that right?
That's right.
All right.
So now here we are able to redetermine whether it is a contract. And then we basically add it to the queue. And you can see that the codex is a little bit out of date, because the append method is no longer deprecated. So in order to append a row, you use actually the concat function, which takes an array of the, let's see how it did there. Contract address, and figured out the last 4 and the first 4, but it did a little mistake here, because the contract address will have OX and then the contract address starts. So we really need the from 2 to 4.
Yes. And then you can just do -4 for string indexing in Python.
That's right, the last 4 characters.
Yeah, Python's not so bad.
Yeah, Python is pretty good. And then, Pandas is also pretty neat. So now here, again, probably something we can enhance. And so let me just kind of add it. Oops. To do. I'm just kind of adding. But we really need to make sure that that does not grow indefinitely, because that would certainly run into memory issues. Okay, so now we can essentially assume that this object will have all the created contracts in the queue. And so now we'll code up is essentially the snippet where we assess a contract creation. So contract creation.
So the DQ thing, just to be clear, what you're doing is just keeping the last, well, you will be eventually keeping the last N contracts seen, just the most recent ones, and then allowing ones that you haven't seen recently to fall off so it doesn't grow too large, right?
That's right, exactly.
Okay, cool.
Right now it would, and probably would quickly run into memory issues. So then we'll declare our list of findings. So that will essentially where we will stick the alert into, and then we will, at the end, return findings. So then here we will, oops, we will look at transactions where the to field is essentially empty. And so that is a contract creation. And so first, again, the created contract address is not part of the transaction, but it's really calculated. And so we will need to implement a function here. It made a favor, yeah. So essentially, we need the from address, so that's the EOA another contract that created this particular contract, and the nonce.
Right.
And then we'll implement this function, calculate contract address. Right.
Because this contract doesn't know, or sorry, this transaction doesn't know it yet. It gets created, and then eventually you can find the contract address. Yes.
That's yes.
Okay.
And in Etherscan, if you look at it, they already kind of do this calculation and show it to you, but it's not contained in the transaction. So then we'll first get the address bytes, and again, address will have the OX prefix, sender to, and then to lower. So we lowercase it, and then we return checksum address with the jack. So this is the hash calculation function, and then there is a particular encoding that you need to apply in order to calculate this, and it is bytes, months.
Recursive length prefix encoding.
Oh, that's a good question, Chad. I don't know.
I Googled it.
Good. And then this will also create a prefix. All right, now we don't have this imported yet, so we need to import that. And then, of course, we needed to add it to the requirements. Now, I don't know what it was. So let me check that for a second.
Looks like 3.0.0. These might be nice things to add to the Forta library, like checking if something is a contract creation and such.
Yeah, that's actually a good point. And I have, found myself, I'm of course cheating here a little bit and peeking at my other window. I found myself implementing like, hey, is it a contract, or calculate the contract address repeatedly. I think that's a great suggestion to add that to the library. It would certainly make this code much even slimmer, and you'll see by the end of it, it's actually not going to be a lot of code.
Yeah, looks like it's almost done at this point. And maybe a Forta utils package, so you don't always have to have all this extra stuff.
Yeah.
If only I coded Python, I might help.
All right, I'm just checking here. I don't know what it is not liking. I'll figure that out.
Is this something's not parsing problem?
Yeah.
If you mouse over contracts queue, does it tell you why it's upset?
Indentation error. Yeah, white space, man. It's was not closed. There you go. Okay, so we're back down here. Okay, so it's just we're not using it. Yeah, we're about to use it. Okay, so we got our contract address. It is lowercase, and so now basically what we would need to do is look in our contracts queue to see whether the first four characters and the last four characters matched. And so in Pandas, do that through criteria that look a little funny, but it's in a way kind of like a filter.
Mm-hmm.
Char.
So this is creating like a filter object that you then use?
It creates essentially a filter.
Yeah.
So we have two filters here, and then basically we will extract the impersonated contract address, where we apply essentially the filter on our queue. So basically, we'll do a select on the entire queue with these two criteria.
Yeah, makes sense.
And then actually, so that is the impersonated contract address matches. So first, we need to check whether we have any matches. And then we can get the contract address. Out of the matches, there should only be really one match. And then we will append a findings object. And the findings object is essentially just a dictionary of values. And so
are the keys arbitrary? Are there conventions, or is it a restricted set?
They are not arbitrary. There are conventions, and it's documented in the Forta doc. You need name, description, alert ID, type, severity, and then there is this field called metadata, which is more of a free form additional dictionary where you can stick anything in.
Okay. So yet another dictionary in there so you can put, yeah, cool.
That's right. Okay, so social engineering contract was created from impersonating the impersonated contract address, and then we probably want to have the created contract in here as well. So let's stick that over here. So then essentially the alert will be the social engineering contract, blah, 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 was created by EOA, blah, 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 impersonating the impersonated contract address. Then we need to set the alert ID. And we get that from our README. That is this alert ID that I mentioned over here. Oops, where am I?
So I assume that needs to be unique for every bot that gets deployed.
That is a good question. I think that's certainly the desire. because Forta has an API, the GraphQL API that allows you to query past alerts. I think okay, let me rephrase. But it needs to be unique within the bot. Like, you don't want to have two different types of alerts with the same alert ID, because then you're not able to differentiate. You could theoretically have alert IDs that are duplicated across bots. Not desirable, but nothing enforcing it either.
I see. Okay. So you can kind of think of the bot as being an additional namespace in the alert global namespace.
Right.
Mm-hmm.
Okay, let's see some imports. Finding type, and again, if we go back to the README, the type was set to exploit, severity to high. String 2.
Yeah, Codex knows that you want to do severity too.
There you go. Good for me. And then we'll do metadata and per submitted contract address. Yeah, Codex suggesting to also stick in the create a contract address. Fine, we'll do that. Who's complaining here? Invalid syntax. No, I just need to save, and then it's fine. Okay. Let's just kind of review here. So we have our initialization. Why is it complaining here? Expected 2 blank lines. Yeah, my linker is complaining.
So since we're doing test-driven development, I have the itch to try to run the test before review. Am I wrong?
Well, yes, let's see what happens.
The worst that can happen is it still fails.
Well, if it's
2 warnings, 1 error.
Make sure you test modules package of it.
Is that the error from before, or is that fresh?
No, well, let's see. Actually, it was the error from before, but it's really complaining about the import name of contract, which...
Yeah, we still have errors in the test file.
There's some ordering. Let's do that.
Does it want you to put the import either first or last, like apart from the froms?
Yeah, I think there's some ordering that it just kind of complains about. Okay, these we are not using, so all right. Yeah, it doesn't show any errors. Let's see whether this works. Oh, you know what?
Wrong Python version?
Yeah, maybe. Maybe not.
Mm-hmm.
Well, you know what? I will just cheat for the
Good idea.
here to get it working. So we'll just replace the actual address, and we don't need to import it, but see what happens.
Yeah, let's see if it's mad about EOA address now.
Okay, sure. All right, now I'm super confused.
Now it looks like it's using an old version of the code.
Yeah. Oh no, now it's complaining about the EOA.
Okay, good.
Um,
We may not know why, but at least that's what we expected.
yeah. I can play the next. Okay, map Mach 3.
This isn't an indentation issue, is it? Like, are there?
Mm.
No, they're all at the same level.
Let me do something here real quick.
People who aren't software developers don't realize how much of the day of a software developer is spent fixing problems that shouldn't happen like this.
Yes,
Okay.
I think I spend way more time debugging than and I don't know what happened, but apparently it's complaining about something else now, right?
It was white space, and now the problem is the variable or the global thing is called contracts queue in your production code, plural.
I think that is an easy fix because it's just contracts queue instead of contract queue. Okay. And let's see what happens now.
The last problem was surely a white space issue.
Yes. Okay, well that's good. We're making progress, and we'll debug this.
This is why we wrote the tests.
Exactly. So
I have a guess, and my guess may be completely off, but in the production code, I don't know Pandas. When you check that the length of the contracts queue is greater than 0, or what was it, impersonated contracts, the next thing you did was get the contract address on line 46.
Yes.
If that's a list, does that make sense, or would you need to get the first element from the list and then get its contract address?
Yeah, that's a good point.
But I don't know if that's what the error says in the test, so I shouldn't jump to that.
Yeah, the error is complaining about the concatenation. Let's double check that. So it's even earlier, right? So it hasn't gotten down here.
Okay.
2, 2, 2. Per column array must be one-dimensional. I think what it was forgetting is that you need to set index. Let's see.
On the couple of times I've used Pandas in the past, it occurs to me that it's almost like its own language. It's such an interesting API.
Yeah, I find myself Googling a lot. Okay, so I think that got rid of that error. So now it is complaining about this one. So handle transaction, calculate contract address. We got the catjack calculation. So it calculates a hash, but then it basically complains that it's not a checksum address. And so I think what I probably messed up here was some of the parentheses where it calculates it on the entire thing as opposed to, yeah.
Right. Yeah.
All right. So now let's see. There you go. All right. So now that we have the unit test passing, let's run it on the two transactions, our test transactions that are. So the first transaction is essentially the transaction where the user interacts with a legitimate contract. And then the second transaction is the attacker transaction where they create the contract that looks similar to that. And so that should then emit a finding. Oh, okay. Initialize missing one required position argument.
It was instantiated without the W3 thing being passed in.
Yeah. Well, it shouldn't really use this one. Hang on, let me just rename this. Maybe I'm overriding something that is utilized by our framework, and I'm really just using that function.
That looks like it didn't save it. Okay.
Let's run it on live transaction, see what happens.
So it does have the same error. I guess it expects the initialize. It expects to have initialize with no arguments.
Yeah, it's very weird. I have not encountered this.
This is what happens when we do demos.
Yeah. Okay, well, okay. So now basically what it is doing is it's running on live transactions that come in, and as you would expect, it kind of shows 0 findings, 0 alerts, and that's kind of my expectation. The reason why I was doing this one is just to make sure that there's no conditions where it essentially errors out.
Right.
And so now let's run it on the 2 transactions.
So where does it get these 2 transactions? Is it querying a node somewhere for these and actually getting them out of the real blockchain?
That's right.
Okay.
It just uses like an infer endpoint and pulls out these transactions.
Okay. So for both of these commands that you just ran, somewhere there is there's a configuration file that probably points to your own personal infer key or something. Yeah.
That's correct.
Okay. Are they not supposed to be comma separated? Is that what the problem was?
Yeah, no,
Or does everything just want to go wrong today for some reason?
Yeah, I'm not 100% sure what's going on here, because also it is talking about that it is running.
a series is a pandas object, right?
Yes.
And it's trying to convert it to JSON. So somewhere we're returning our data frame where we don't expect to, I bet, passing it into something that doesn't expect it.
I mean, it must be related to kind of the run transaction command. So maybe I got the format wrong here, but you do need to run in 2 transactions in order to get to it. But I know we're already over time, but we have the unit test passing. So let me just kind of show you how to publish the bot. And it's basically just simple as a command like run npm run publish, and I'll run it. But this will take several minutes, and I can explain briefly what is happening here. So basically, it will build the Docker container. So all the dependencies that we mentioned here in the requirements will be pulled down. It will build that Docker container. Then it will upload that Docker container to IPFS. So the Interplanetary Global File System, which is a distributed file system. So then essentially the Docker image is then available in the cloud. Then it will register this particular bot with the Forta network. And that is actually a transaction on the Polygon blockchain. So basically you sign a transaction saying, hey, I want to deploy this bot. The network sees that and then essentially takes the bot and assigns it to usually about 6 scan nodes.
Okay, so scan nodes are computers that are running Docker somewhere that have agreed to be part of the Forta network.
That's right.
Yeah. Does it, like, have you somehow created a wallet or a key pair before you did this?
I did.
Okay, so it knows that it's you, at least it's you as identified by your Polygon wallet, and that's what you're signing things as. Yeah.
Right.
Cool.
And then once that happens, the bots, the scan nodes will essentially download the image that we just created from IPFS and start running it. And so let me just kind of show you. So I did this yesterday. Usually it takes about a few minutes. It's really not that long, and it's pretty impressive that you go from, hey, I'm done with my bot, to getting alerts within a few minutes. So let me show you how this then looks on
the Explorer.
Exactly, on the Explorer.
Cool. So is it permissioned, or once I've deployed it, it is going to run on these scan nodes?
Yeah, once it's deployed, it is going to run on the scan node. So there's nothing that is controlled. Like, wow. It automatically deploys on these nodes. And so here's the social engineering contract creation that I have created yesterday. You can see that it is deployed on the 7 EVM chains. It's enabled. You can pull up the documentation that I talked about.
Nice.
And
can you see that it had findings?
Yes.
Yeah.
Down here essentially is alerts per day. So if we look up at another bot, let's see whether there's maybe some test bots back here that maybe are a little bit more noisy. So 2 weeks deployed. Yeah, so here you essentially see kind of a visual representation of all the alerts since deployment. And then down here, you see all the alerts. Now, our bot is pretty specific, so I wouldn't expect it to alert much at all. But now the question is it running? Is it operating appropriately? And so there's the log data that you could pull up. So in the bot that I deployed yesterday, I added log information around whenever a contract gets added to the queue or dequeued. And so it is running happily. And so I am subscribed now, or I can subscribe to this particular bot.
And here you say you could have it either go to an API endpoint or to your email. Oh, I see. Slack, Discord, Telegram. Excellent.
Yeah, you kind of manage your subscription through the wallet, through the Forta app, because you kind of authenticate there. But then you can subscribe to it. You enter the bot ID, which was this guy right here. And then enter your email address. And hit subscribe. And you sign another transaction to get that going. And then you see it in your subscription. There is going to be some email verification, just kind of for spam purposes. And then you get your alert.
Great. And we're done.
We're done. It took a little longer and a little bit more troubles along the way, but that is coding for you.
That is the nature of programming. Yeah. And we can blame the white space for everything, right?
Those darn white spaces.
Cool. And would you say that using Infura is the best way to run things locally, or there are other options?
Well, you can certainly have a node as well. You don't need to have a full node. You can have a light node. And so then at least you're not dependent on Infura. But Infura, of course, is very quick. Alchemy is another service provider. So there's a few out there. And again, running a node locally is not a big hurdle either.
Right. And then the scan nodes, that's also open. So I could decide to run a scan node now, or a bunch of them, and stake and be rewarded for participating in the network, right?
Absolutely. And if you... let's see here. If you look at our network today, so you can go to the network page, you will see all the chains and then the number of nodes that are currently deployed on the network, as well as the detection bots that are deployed on those nodes. Right now, I kind of squint, that's 7,000 nodes. It's been growing quite significantly over the last few weeks, which is great to see, because it seems like community is really supporting the Forta network and securing Web3.
Yeah, it's one of those things where for you to this is one of those projects where if you shill it, you're actually shilling for the public good, not for the benefit of a company, which is a lovely thing about promoting this kind of stuff. The more we see these things, the better off we will be. Great. Well, thank you so much for this explanation. Now I feel like for the first time, I'm actually capable of going and sitting and probably spending 3 times as long as I expect, but eventually producing a bot that might be useful.
Yeah, Chad, I look forward to seeing your deployed bot.
All right. Thanks.
Well, thanks so much. This was fun. Thanks for setting it up.
Yes, thank you. And see you next time.
Yeah, see you, Chad.